Alright, this is the last section of semester 1. So related rates is where we want to look at the rate of something changing with respect to time. And so we're going to use the chain rule to kind of do, I don't know, step-by the chain rule as we do this. And again, the why comes from your vocabulary. Related rate problems are at the heart of Newtonian mechanics. It was essentially to solve such problems that calculus was invented. And then this is my extra stuff. Also, this is going to be on the exam. So, if you're not as excited about Newtonian mechanics, this is part of why calculus. So, let's start. Look at this lovely conical water tank. How many of you have a conical water tank? You do? First of all, if we want to talk about a conical water tank that is filled with water and is draining, we're talking about the volume. How much does that water tank hold? So we have to know the volume of cone. Right? The good news is, on the AP exam, they're not going to make you miss a problem if you don't know the volume of a cone. Like in parentheses at the end of the prop up, they'll be like, volume of a cone is this. They do expect you to know area to triangle, area to rectangle, but volume, we take the area of the base, which would be what? And then we would take the height, which is the perpendicular distance. 2 pi, or just pi r squared h. Isn't that how it looks like? 1/3 of this volume. Because we want to find the rate that the volume is changing. Rate means derivative. So notice I put dv over dt. That's with respect to time, right? So this is where we don't really just want to say d prime. It's really kind of important, I think, that you show that you're taking the derivative with respect to time. Which means there is no time in this problem. Which means every time you take the derivative of a letter, you have to multiply by, like for r, you would multiply by dr over dt. For h, you would multiply by h over dt. Because that would be how the rate is changing with respect to time. The rate of a height is changing with respect to time. Also super fun, I'd have to do a product rule to take the derivative here. Yes? Probably the biggest mistake I see on the AP exam when we start practicing the AP exam is people just do like 2r, dr, h over dt, and they forget all about the product rule. That's still not clear as well. 1/3 pi, that's just a constant, so that's just a mistake. 1/3 pi. You can totally. And then the derivative of r squared is 2r. But I'm doing this with respect to time. So I'm going to say times dr over dt. Leave the h alone. Plus psi-third. Now I'm going to leave r squared alone. And the derivative of h is just 1. But I'm going to multiply by h over t. Do you agree, as that water is draining out, it's not going to always, in a real problem, this was kind of just to introduce you, they're going to give you information so you can plug stuff in and find for what this is. But in this one, could we kind of rearrange this? Could we make it look any better? Can't factor anything out? You understand what I do? I can factor out a pi-third. You want to? You don't want to? I can factor an r. I can factor out an h. Pi r third h over dt. And what we can say is that the rate of the volume is related to the rates of both the radius and the height. So whenever they say rate, you got to know that means derivative. So I don't know if rate I think one of the hardest things when it comes to AP exam is this doesn't come up that often. But like reading it and realizing, oh yeah, I have to do this different times and then plug values. Once you get that, it's just so I kind of gave you some guidelines, kind of like I did with the optimization stuff. I don't know why number one's underlined. That's not what it's supposed to be. But first thing, identify all givens and quantities that need to be determined. Make a sketch if you need to. Probably number 2 is my most important one here. Write an equation involving variables whose rates of change are either given or to be determined. This kind of goes against what we've normally done. Normally when we write an equation, we automatically plug in what they give us. If they gave us the radius was 7, we would plug 7 in right away. But if you do that, and you take the derivative of 7, you're not going to get that dr over dt, right? Because they're going to tell you the radius is 7 right now, but what happens when the radius changes? So you have to make sure you don't substitute in any known values until you take the derivative. So then step 3, you're going to take the derivative with respect to time, and then you can plug in what you know and you can solve for what's left. This has shown up on both the multiple choice and the free response, and the plan is tomorrow we're going to look at some of those questions that have shown up on the AP exam before, and see how they're a little different than what we've seen. So, here we go. Let's start easy, and then we'll get excited. Like story problems, this is exciting. It just says let f of x equals x cubed minus 4x if dx over dt equals negative 2 centimeters per second. Okay, that's like the rate that it's changing. Find dy over dt when x easy thing. What makes this problem easier than story problems is they give you the equation, so you don't have to worry about what the equation is. What maybe throws you off from this is normally when we take the derivative, we're doing it with respect to x. So we want to just say that's 3x squared minus 4. But remember that this is with respect to time. You know that they say dx over dt, y over dt. So you have to remember when you take the derivative, maybe y of x. So when I say I take the derivative of y with respect to time, I say y over dt. And then the derivative of x cubed is still 3x squared. We're going to have to multiply by dx over dt minus 4 dx. Right? Every time I take the derivative of x, I'm going to multiply by dx. And then if you want to simplify it, you can. But you should be able to just plug in the values that you need now, right? So they tell us with x is negative 3, we're going to plug that in for x. They tell us that the rate that x is changing when x is negative 3 is negative 2 centimeters per second. And that's it. That's all the unknowns we have except for dy over dt, which is what we find in time. 1, 4. And since we don't really know units on this, on story problems it's easier, so you don't really have to put units on it, but I'm assuming if X is changing centimeters per second, X is also a rate, so that would be centimeters per second. But it's easier when you have a story problem that you actually know. The radius of a circle is increasing at a rate of 2 inches per minute. Find the rate of change of the area when the radius equals 6 inches and when the radius equals 24 inches. Which means they give you two parts, but once you find your equation and take the derivative of it, like part A and part B are just close to each other. So if you're trying to find the rate of change of the area, that's your equation, right? So what's the area of the circle? So we're going to take the derivative of it. We're not going to plug anything in. With respect to time, do I need to do the product rule on this? Hi's a number, not a letter. So again, this is where I write it as dA over dt, because if you just write a time, it's not really showing that you're doing it with respect to time. My derivative here, IR, don't forget, with respect to time, is your dr over dt. And now we can plug in the values that they give us. They tell us that the circle is increasing. So they tell us that the radius of the circle, so they're giving us dr over dt is 2 inches per minute. They asked us to find the rate of change of the area, which means what you're looking for should be dA over dt. So if you ever kind of get confused about what do I know, what am I looking for, sometimes it's helpful just to write that out. The question on the old AP exam, where they gave you points, if you just wrote out what was given to you, like in that form, like if you wrote dr over dt and then whatever that given information was, they gave you one of the 9 points that that question was worth, like just saying you knew to write that entry. So, not a bad idea to kind of be aware of that. So for part A, 2 pi, and the radius is 6. So we can think about this is 6 inches, and the dr over dt is 2 inches per minute. Uh, 24 pi, and my units would be. And again, hopefully that makes sense, that if we're talking about area, that the rate the area is going to be changing is going to be in square inches per minute, if the radius is changing in inches per minute. If you're unsure about units, you can always plug them in like I did here, but again, sometimes you can just use what you know about units. And then part B, all you do is you change from 6 inches to whatever. Six pi, and again, I just left pi in there. lot of times questions like this will show up on the no calculator part of the multiple choice, because it's not bad math to do without a calculator. It's just knowing how to do it. You're like, yeah. Got some picture of the guy running the base. A baseball infield has the shape of a square, the side 90 feet long. A player 30 feet from third base is running at a speed of 28 feet per second. At what rate is the player's distance, S, from home plate changing? First question, 28 feet per second. Times 60 per minute, feet per hours. Is that right? Am I going to change that? You look at me like 19 miles per hour. That's pretty quick for a baseball. Whenever I see that, feet per second. No, because we need it in feet. Okay. A player 30 feet from third base is running at a speed of 28 feet per second. At what rate is the player's distance S from home plate changing? So we are looking for the rate of S. Do you agree with that? So like our unknown values that we're not going to find until the end is ds over dt. You can talk about our other things they give us, but remember, you don't want to plug those in yet. But we can talk about, we know that the player is running at a speed of 28 feet per second. We know this is 90, right? Is that true? We actually also know that how far away is this player from third base? We know this is 30, but notice I put an X here for meaning like we're going to need that as a letter at some point, right? So like this is going to change. So I'm going to say 30 right now, but know that in our equation we don't want to plug 30 in yet. Look at this lovely shape of these things. Look at the shape of these things. Ooh, a triangle, and even more specifically what kind of triangle? A right triangle. So if I want to try to make a relationship between these values, not using area, not using volume, because in the baseball infield, in the overlaying this, isn't that what it goes through? But it's just a straight term cycle because it's 90 seconds. We don't need to check. Last year I just checked it out. I checked because Mr. Love argued with me about how far the mound was from the plate, and we went out and we measured it with the I don't. Well, that's not true. If this is 90 and this is 90, I'm telling you, this is actual. These are real numbers. This is not made up. Maybe running 20 feet per second. That's the flow in psychology. Why do you want to be up here? They're really supposed to be great. I'm going to write an equation, the Pythagorean theorem relationship. Even though I know that he's 30 feet from base, I have to use a variable because every second that goes by, that's going to change. You agree with me on that? So the 30 is going to come into play later, but right now it's x. What about the 90? Is the 90 ever going to change? So do I need to use a variable for 90? Because the 90 is always 90. And then s is the hypotenuse there. Is s going to change as that runner keeps moving? So I guess maybe I should restate what I was saying earlier about don't plug in any of your known values. Don't plug in any value that could change as time changes. Because we're doing this with respect to time. If it's a constant value, like the distance from third base to home, that's never going to change. So that's why that can go in. Take the derivative. So the harder part in the story problem sometimes is coming up with the equation, but I'll tell you, there's one of your homework about a ladder falling. House, again, with respect to time, come on, so let's take 2x, x over dt, plus, what's the derivative of 90 squared? 0, right? 90 is just a constant, it's a trick. Equals 2x. With me on that? I don't know the s over dt. So I'm trying to find, which means I should either know or be able to find all the other missing values. So at the moment that we're talking about, what is x? 30, right? He's 30 feet away. Do I know the x over dt? Do I know s? I can find it, right? So that's where we don't know it by what's given, but using that right triangle, if we know that x is 30 and the other side there is 90, we could do the Pythagorean theorem and find what s is, which is what you have to do in this problem. So s squared would equal 30 squared plus 90 squared, so s would just equal the square root. Oh, so the square root of 90 is? Is that true? 9,000 break up as 9 times 126. Is that true? So 3 times the same, is that the same as 30 squared again? I'm going to do that again. Okay, we want to talk about whether rates are positive and negatives right now. Or we want to wait about that. Because on the last problem, they gave us, but on this one, they gave us a rate of a negative value. What do you think that means if a rate is negative? Think about, okay, let's look at this. If we're talking about area, we found that the rate, it says, the circle is increasing at a rate of 2 inches per minute, which means the balloon, but the circle. But it means the circle is getting bigger at a rate of 2 inches per minute. What do you think if it was saying if it was decreasing at a rate of 2 inches per minute? it would be a negative rate, and that means the circle's getting smaller over time. And so when we're doing story problems, we have to think about, is the rate we're looking at, is the value getting bigger or is it getting smaller? So let's look at this. Look at these two values. One of these is going to get bigger as the guy moves, and the other one's going to get smaller. One of the two x's. Good with that? Like as he runs, what's going to happen to the value of x? It's going to get smaller, and what's going to happen to the value of s? It's going to get larger. And so you have to make sure that your answer, if we did this as we have it right now, we're going to solve this for s, and I think we're going to get a negative rate. And we should say that doesn't make sense to us, because that should be getting bigger, not smaller as we grow. Well, yeah, we're just, we're going to say he's going to stop at certain. We're going to say that he's going to get to certain stop. It's going to take it right around it. So I just want you to be aware of that, because if you didn't think about it, look at your answer and see if it makes sense. But I think, because we're thinking about it, that we should say that dx over dt is a negative 28 feet per second. And it's not that he's running in a negative direction, or whatever you want to think about it. It's just that that x value is getting smaller as he's running towards surface. Now you have options. We're solving for ds over dt, so we can just plug everything in and move it over. Or if you prefer, you could just divide this over first and then plug in everything, right? Like it's your choice. I tend to go the algebra route, and I like to divide this over first. And I'm going to say that ds over dt. Is that right? Am I right? Have I messed it up? That's the hypotenuse already, right? I'm thinking that x was smaller than 90, but x is bigger than 90 right now. And as he runs closer, x is going to equal 90. When he gets to third base, the hypotenuse is now the length of that leg. So s should be negative, which is the right thing. I was just overthinking it. For some reason, I was thinking that that was bigger. 90 was bigger than 90. So that does make sense there. And notice I gave an exact answer for now just because I didn't want to deal with the negatives. But if we're talking about his rate, probably at this point it would make sense to give a decimal answer. If this was a multiple choice question on the no calculator, then obviously you would leave it as negative 28 over x squared. But if we go to 3 decimal places, we would get negative 8.854. And we can plug all the values in there, but the length or the distance is going to be in the same units, right? It's still going to be in feet per second. If we wouldn't have plugged in a negative, we would have got a positive answer for x, and then that should have been that way. Okay. I put some formulas there for you in case you don't remember them, that there are some questions on your homework talking about a spherical balloon, and so you need to know surface area of a sphere, which is 4 pi r squared, and volume of a sphere, which we happened to use in college algebra yesterday, 4/3 planar cubes as you're doing some of those problems. Only 5 problems, but some part A, number 19 is about a ladder falling down, which is very similar to the baseball problem, except for now it's a ladder and we're talking about the distance from okay? This is really it. Tomorrow I just